Welcome to the Inside Java podcast, a podcast that discusses Java made by the people at Oracle who makes Java. My name is David Delavasse, and I'm your host for this episode. Java is moving, one JEP at a time, to support pattern matching. In JDK 17, pattern matching for Switch will be previewed for the first time. I recently had the chance to discuss this with Gavin Bierman, who worked on that new Java language feature. So enjoy the show. Hi, Kevin. It's great to have you, as you were one of the very first guests of this podcast. So if I recall correctly, it was around the Java 14 time frame, and back then we discussed records, right?
That's right, and I'm very happy to say that we've finalized records. They shipped in their final form in JDK 16, and they've been very well received. So I'm very happy to tie up that knot for you.
Yeah, cool. So welcome back. So for the people who don't know you, can you quickly introduce yourself?
Sure. So my name is Gavin Bierman, and I work in the Java platform group. I'm part of the small team that designs the Java programming language. So we develop ideas and prototypes and documentation and push them through all the way to the end.
Okay, so today we're going to discuss pattern matching for Switch. So in Java 17, we are previewing for the first time pattern matching for Switch. I believe this is JEP 406. And this JEP adds to the Java language pattern matching for the switch expression and the switch statement. So first, and to make sure that we are on the same page, I think that it might be useful to explain the general concept behind pattern matching.
Yes, that's great. So pattern matching is quite a big topic, and we're pushing it out into the Java language in small pieces so people can get used to it and get to see the beauty of pattern matching. The general idea about pattern matching. So what's a pattern? So a pattern is basically a test. It's something that you can test a value against. And you can say, do I match this pattern? So it's a bit like a template, although that word is somewhat overloaded nowadays. And the idea is that a value will either match the pattern or it doesn't match a pattern. Now, the pattern itself can contain holes because you want to just not specify all the details of every part of the value, but just put placeholders in certain places within the pattern. And we use variables to represent those holes. So they're just like local variables, except we give them a special name just to make sure you know what's going on. We call them pattern variables, but they're exactly like local variables. So if a pattern matches, then the pattern variable, the local variable mentioned in a pattern, is initialized with the value contained within the value that it applies to. So that's the basic idea of what a pattern is and how pattern matching works.
And the first form of pattern matching in the platform is pattern matching for instanceof. Can you tell us more?
In JEP 394, which again was a finalizing JEP in JDK 16, we extended the instanceof expression to support a pattern as its second operand. So I'm sure everyone knows that up to that point, instanceof just took a type on the right-hand side. So you could say, is this an expression, an instance of this type? So at runtime, the value would be compared to the type and would return true or false. We extended instanceof so it could take a pattern on the right-hand side. And the semantics then is, does this value match the pattern? And in the process of matching, any pattern variables inside the pattern, should the pattern actually match, would be initialized with values that you could then use in later parts of your program. We restricted things, again, to keep it simple and not too complicated to begin with. We restricted the sorts of patterns that you could use to just type patterns. So type pattern basically does what it says on the tin. So it just says, are you of this type? Can you be cast to this type? And if you can, here's a variable for you to be initialized with. So that's as I say, now a standard feature of the language from JDK 16. And what people are starting to see now is the much bigger story of pattern matching unfolding. So the next step in unrolling pattern matching to the masses is supporting pattern matching in Switch.
Okay. Now, before we talk about pattern matching for Switch, so you said that pattern matching for instanceof is standard in 16. It has been previewed 2 times. In 16, is there any major change in pattern matching for instanceof?
Yeah, so the only change that we made was in the earlier previews, we made pattern variables implicitly final. But we decided to change that because we know of things that are coming in the future, and we realized that that was probably not the right design. So for the standard version in 16, pattern variables are not implicitly final. If you would like them to be final, you can declare them final just as you can a local variable. Pattern variables are exactly like local variables. So if you would like them to be final, you just declare them to be final. So that was the only change we made from the second preview.
Okay. Now let's jump to the meat of the podcast, pattern matching for Switch. So that effort builds upon some work that was done in Ember that we already mentioned, pattern matching for instanceof, Silk class, but also the new Switch expression. So can you explain at a very high level how pattern matching for Switch works?
Sure. So once we've added pattern matching to instanceof, it becomes quite common that people start writing big if then else chains where they say, if this is an instance of this pattern, then do something. Else, if it's an instance of this pattern, do something, and so on. And we'd really like better code than that. We already have a feature in the language to allow a sort of multi-place conditional, and that's switch. So the next natural location for us to enhance with pattern matching is the switch statement. Now, I'm sure your listeners know what a switch statement is, but basically we have an expression that we're testing. That's called the selector expression in the spec. And then we have a block of code and it has some case labels. And prior to this preview feature for pattern matching for Switch, their labels were just constants. So they might be little integers or enum constants or string constants. And the idea is you evaluate the selector expression and then you find the label that is equal to the value that you got, and then you execute the associated code, the code that's associated with that case label. Now, what we're doing with this extension is we are enhancing the sort of thing you can write for a label. So it's no longer restricted to be a constant, but it can be a pattern. So in our case, we have type patterns. So you can now write, for example, case string S. String S is a type pattern. Now, instantly, this brings you to the first kind of major change to Switch, actually, which is currently Switch is restricted. It restricts the types of the selector expression. So all the labels are just constants. So the only thing you can switch over are values, expressions of an integral type like int, or an enum type, or a string, and nothing else. Now, that doesn't make sense if we're going to add our beautiful type patterns and say, are you a string S, are you a char C, or whatever. So we're actually relaxing that restriction on switch. So switch can now switch over anything, so anything that has a type. So that's the first change. And then the second change is to support this new form of case label where you can say case followed by a pattern. That's, I think, the essence. But of course, like all things to do with extending the language, there are lots of consequences.
Yeah, especially that Switch is not necessarily an easy construction.
Exactly.
One question. So you mentioned that new type of case label. Do they have a name?
Yes, so we call them pattern labels. We'll see if that terminology sticks.
Okay. In the JEP, there is this concept of dominance of pattern labels. I wasn't entirely clear about that, so can you clarify that?
I'd be happy to. I'm sorry it wasn't clear since I wrote that, Jeff. But
I'm sorry.
thank you for the opportunity to clarify.
I'll edit that.
That's fine. Yes, I'd be happy to clarify that. It sounds hard, but it's actually a very straightforward concept. So let's take an example, right? So imagine you've got a switch block with two pattern labels. One is, say, case object O, and the other is case string S. Now, obviously, everything that matches the first pattern, the object O, also matches the string S pattern because every string is an object. So what we mean, if we had a block with those two pattern labels in, it's pretty clear that what we mean is that the string S type pattern really ought to be attempted first. We take the selector expression, we evaluate it, and then we see, are you a string? If you are, I know what to do with you. If you're not, then I'm going to test to see if you're an object. Of course, that's a special test, but that's by the by. Now, the question is, what do we do about this? There's a natural order there, but what do we do? Do we try and make the compiler super smart to just work out in your big switch block which one comes first, which one would come second, which one would come third? So there are languages out there that have attempted to do this, where the compiler automatically analyzes all the pattern labels and works out the correct ordering of the labels. But I think, unfortunately, in those languages, that sort of approach tends to run out of steam. You end up in cases where the compiler doesn't know what to do, and that can be a bit annoying. But moreover, and I think much more importantly for us as designers of the Java language, is readability. And if you take a big switch block and you've got to figure out the ordering that the magic compiler has worked out for you, that really is not so readable code. It would be much better if the user just wrote it in the correct order. And the correct order is, in these cases, actually very straightforward. The correct order is the string first, then the object. These are type patterns, so you want the subtypes first and the supertype later. So what the compiler does is it just checks that when you have a type pattern, none of the type patterns that follow it are going to kind of never get matched. There's no possibility for them to match because they've been matched by an earlier one. So it's sort of analogous to unreachable statements, which again is another check that Java compiler does for you. It would be a sort of an unreachable pattern label, right?
Mm-hmm.
You're guaranteed to have matched earlier than that. And that's probably a mistake on your part. So this notion of something kind of dominate or hiding another pattern is what we call dominance. But it's a very straightforward test. I think it's very intuitive for users to get the ordering right, and the compiler errors can help you figure out what you've done wrong if that ever happens.
Okay, that's more clear. Thank you.
Pleasure.
Something else. Can we discuss completeness? Something that I saw is that in some cases, switch statements will have to be complete too, right?
That is correct. Happy to discuss that. Completeness was a feature that actually appeared with switch expressions in JEP 361. Now, the idea there is obviously when you are evaluating any expression in Java, you expect it to result in either a value or an exception. So when we introduced switch expressions, we had a question for us in the design process, which is, what if your cases didn't cover all the values that could arise from the thing you were switching over? So imagine we were doing a switch expression over an enum. What if you forgot one of the enum constants in the case labels? Well, the problem there is if you would allow that, That's got to be an error. But which error would you like? Well, then we're going to have to invent another magic exception name, a matching exception or something like that. We decided that probably this was actually an error on your part. Most likely you just forgot that enum constant. So actually the more useful thing would be for the compiler to flag a switch expression that was not complete, that didn't have cases for everything as an error. And then if you really wanted an exception for your particular enum constant, well, then you throw it yourself. And if you wanted to write, say, a switch expression that did something very particular for two enum constants and something else for all the others, well, you would write that as a default. And so we had a simple check for switch expressions, which looks at all the case labels and just says, have you got a case here or a default? Is there something for every possible value in this expression? Otherwise, it's not going to be an expression. There's going to be a case where we don't know what the value or the exception is going to be. Now, as we move on to extending switch with patterns, we get to a similar question. So obviously for switch expressions, we have to enhance the notion of completeness to deal with the fact that the case labels are no longer just simple constants, but they could contain patterns. So we need to look at the patterns and just say, hey, is there a case for everything here, or is there something missing? So we just lift it up. And there's a very interesting case here, an interaction with sealed classes, another feature that's actually finalizing in JDK 17, which is the idea that you can take a little inheritance hierarchy and close it up. So it's a very beautiful feature, and we're actually now changing some of the classes in the Java API to be sealed because we don't want people to subclass them. We've said it in documentation, and now we will actually stop you from doing it, which is very nice. Now, the cute thing is that if you are switching over, say, a sealed interface that has specified that it, for example, has three subclasses, three permitted subclasses, now, if you have a type test for each three of those permitted subclasses, you don't need a default because the compiler already knows, aha, there are only three subclasses allowed of this interface. I see them all as type patterns in the switch block. Okay, no default is needed. I have a case for every eventuality. So we've lifted this notion of completeness up from simple case constants to pattern labels. So that is very cute. And we've noticed from feedback from users about switch expressions is that they really like it because the compiler does extra checks for them, right? And it spots dumb mistakes. And one of the problems with switch statements as they exist at the moment is that if you've forgotten a case in a switch statement, the switch statement just silently does nothing. It evaluates the selector expression. It says, is there any case label or default? Let's imagine there's no default. Oh, there's no case label? Okay, I'm done. And it just carries on as before. And this sort of silent behavior leads to really tough to debug situations where you'll write somewhere else in the code and you go, but hang on, this thing hasn't been initialized or whatever, or some value hasn't been set in the way I expected. And the compiler can't help you. But for switch expressions, that can't happen because it required the body to be complete. So we've made a decision in this preview version, and I urge everyone to try it out and let us know how they find it, to say if you are a switch statement of a new variety, and by new variety, I mean using any one of these new features in this JEP. So using a type of the selector expression that you weren't allowed to use before, or using a pattern label, or using any one of the other new labels that we're adding in this, then you are a new switch statement. And if you're a new switch statement, then you have to be complete too. So we're now bringing switch statements and switch expressions together. Obviously, we can only do it for the new style switch statements, because if we enforce that for every switch statement, then it would be a breaking change to the language, and we're not that cruel to our users, so we're not going to do that. But it's a very simple restriction. It sounds quite hard, but for the most case, if you really want a silent switch, so something that says, oh, if it's any one of these other things, do nothing, then just write default : break, and then you're done. Then you're complete, right? Because that covers everything else. So it's a very simple change to your code. It makes your code very readable, because now when you switch, you have a case label for every eventuality. Even if it's one where you just say the outcome is do nothing, that's okay, still very readable. And now the compiler can do checks for you. You have no silent switches anymore. Everything's checked. And we get these nice properties like switching over sealed classes and so on can get cute compiler checks and so on. So we think that this is a way of, I think Brian Goetz referred to this in a recent posting as rehabilitating switch. So, you know, in switch expressions, Jet, we did another improvement to switch actually, which was addressing the common complaint about switch, which was fall through. And people were saying, why do I have to keep writing breaks everywhere? I wish it wasn't fall through by default. So we added a new sort of label, which is the arrow after the case label, which said, I am not a fall through switch anymore. So when you got to the end of the code associated with the arrow, you didn't fall through, a break was magically inserted for you. So we've kind of rehabilitated switch. Now, if you rewrite all your switches with arrow form, you get no fall through, which is nice. And now with this new switch completeness, if you are using a new style switch, you don't get this silent behavior either. And now I think your switches will become much easier to read and debug.
Yeah, so no fall through completeness basically means no more embarrassing bugs that you discover way too late.
Well, hopefully.
Okay, let's see. Something else that I'd like to discuss, total type pattern.
Yes. So this is, again, something that sounds scary, but is very simple to understand, which is if you have a type pattern in your switch, and the type of that pattern is a supertype of the thing that you're switching over. So imagine you say, I've got some string, and I switch over the string, and I say case object O. Now that type pattern always matches, right? Because it's a supertype of the string. So we give that a special name. It's a total type pattern. Now there's a very special behavior of total type patterns, which is intuitively, you would expect every string to match a type test pattern case object O, right? You would expect it because it's a subtype. And in particular, you expect that for all values. But, you know, we have this very long-standing issue with everything in Java and other languages like Java, which is the dreaded null value. What do we do with null, right? What we do is that if you are a type pattern that's total, then that will match null too, because you have said, I am a type pattern and I'm bigger than your type. So I will match every value without inspection. I don't need to look at your type. I know I match. So the null value will match a total type pattern. So this is kind of an important distinction. And it brings me to another point that I wanted to make about switch. So thank you for that, which is that prior to this JEP, switch had a very important design feature, which is that it threw an exception, a null pointer exception, if the value of the selector expression was null. So it would evaluate this selector expression. If it was null, it would throw a null pointer exception without looking at any of the body of the switch block at all. Now we're enhancing switch to do pattern matching and more complicated things that are coming in the future, complicated and exciting. that seems like an unsustainable design decision. So we've done two things actually. One is that if you have a total type pattern in the body, that will match a null value. So we don't throw instantly a null pointer exception. And in fact, we've added a new case label for you to be even more explicit if you want to be, which I think is going to be very useful, which is that you can write case null in the switch body. So it's no longer the case, you're probably familiar with this when you write your code, where you want to switch over something, but before you do, you just better check that it's null, right? Whereas what you really want is to put that null case in the switch body. Now, I think it was entirely reasonable design decision from our predecessors, so I'm not criticizing it, because they restricted the types that you could switch over. So null really was a kind of weird, rare case. But for us, now we are putting patterns on the case labels. Null is quite likely to flow through, and we need a way to deal with it within the switch. We don't want to have to put all this weird null checking stuff at the start before you do a switch. So we're going to allow you to write case null. So you might want to put that at the start, perhaps saying, hey, if I'm null, I'm going to throw. That's probably what most people will do. But maybe the right thing is to initialize a variable to a negative value or something like that. And total type patterns will also match null. So what we do is we've done this in a very careful way. So we haven't broken or changed the semantics of switch at all. So if you switch over a value, we evaluate the expression, we look at the value, and then we look at the body and we say, hey, is there anything that can match null here? So if it evaluates to null, we look at the switch labels and we say, hey, is any one of you either case null or a total type pattern, right? Because those are the things that match null. And if you are, well, then we'll choose you as the winner. And if there are none, now at this point, we're going to throw a null pointer exception because you have not told us what to do for null. And so that is an exceptional case. And this then becomes a conservative extension over the design that we had before, meaning that you now get exactly the behavior you had before. But if you use these new values, everything works smoothly. So it's a sort of non-breaking change. And again, I think this will make Switch a much more usable construct in the future.
That's great. Now, pattern variables. So pattern variables have been introduced with pattern matching, for instance, of. So are there any change around the scoping of pattern variable with this new JEP?
Well, again, we were very careful to design the scope of a pattern variable in instanceof to kind of match the intuition that anybody would have, right? So we did it that if you matched in an instanceof and you were contained in a conditional statement, then if the test succeeded, well, we would expect the thing to be in scope in the true block and not in the false block. This is very intuitive. We're doing a similar sort of intuitive thing for Switch. So, as I mentioned earlier, we have two sorts of labeling schemes in a Switch. We have the arrow form, where the thing on the right-hand side of the arrow is an expression or a block or a throw. Or we have the old style colon with the full through. And again, the colon one is labeling a group of statements, is the way the spec describes that. So the simple extension for scoping for a pattern variable that occurs in a pattern that's in a label is the thing on the right-hand side that it's labeling. So in the case of the arrow form, it's either the expression or the block or the throw statement. And for the colon form, it's those groups of statements that it is labeling. Now, we do one careful check for you, which is if you're in the old style fall through case, we don't let you fall through another pattern that introduces a variable. Because if you do that, then at some stage you're going to start wanting to use that variable and you haven't matched against that pattern, you've just fallen through it. So you won't have a value. So we'll check that. And if you've got code like that, there will be a compile time error. So you can't fall through a pattern label that introduces variables because obviously those variables won't have been initialized. So that's an error. But otherwise, the scoping is exactly what you would expect. It's just the things that you're labeling. Hopefully, it's fairly intuitive to users.
Yeah, I think it is. Okay, something else. What about guarded patterns and oh boy, parenthesized patterns?
Yes, that's right. Yeah, they're a mouthful, but they're very simple to explain. So we noticed when we were trying out pattern labels in Switch, it became very common for you to write code such as the following, where you'd say case, I don't know, string S, and then what you want to do in the body is say, well, if it's a string, I don't know, length 1 or 2, then I would like to return this. Otherwise, I return this. And so we ended up with lots of if thens on the right hand side of the label. And we realized that it would be much more readable if that test, the additional test that was on the right hand side, if that could move over onto the left hand side. So you can end up writing very nice pattern labels, which we call this special form a guarded pattern. So the idea of a guarded pattern is that it is a pattern and a Boolean test. And we use the double ampersand notation that everybody knows and loves. So you can write, for example, a guarded pattern string s and s dot length greater than 2. So that now would match a value that is a string and its length is greater than 2. So you can now write those a sequence of these patterns on the left-hand side, and you get very nice looking code where you say, oh, case string s and length equals 0. Case string s and length equals 1. Case string s and length greater than or equal to 2. So you have all three as separate pattern labels in your block. And we think that this really leads to a much more readable code because you want to specify those cases as separately rather than saying, okay, I've got a switch, but now I have to jump into a big conditional in the body of the thing that you're labeling. So we think that will lead to much more readable code. It's a feature that exists in other languages, but there's traditionally been a choice about how to represent this. You either represent it as a new sort of pattern, or you represent it as something special that you add to switch. So you might say instead of ampersand, we might write, I know, where or when or something. So introduce a new keyword. We've thought about it hard, but we think probably adding a new form of pattern, so a guarded pattern, which is pattern and a Boolean expression, leads to slightly more compact and more useful code when it is used with other features. So that's one new form of pattern that's coming with this JEP. And the other is the ability to put a pair of braces around a pattern, which we didn't really need before, but we need now because making the choice of double ampersand for a guarded pattern does lead us into a couple of parsing cases. So having the ability to bracket some of your patterns is very useful. So we just added that. But again, things just work as you would expect.
Okay, I get the concept. But why such a name, guarded pattern?
Well, the idea is that the Boolean expression is a guard. So it guards against the full pattern matching. So it's kind of existing terminology that we're hopping on. But as you say, it's tough to pronounce.
Especially for a French-speaking person.
Yes.
Okay, well, we already talked more than 30 minutes on pattern matching for Switch. So is there anything else that you'd like to talk on that subject? Maybe give us a glimpse about some of the things that might happen?
Yes. We've got some other JEPs. In fact, we have one JEP that's already available, but doesn't target 17 in preview, but we're hoping to target 18, which is, again, the next step of pattern matching for Java. And that's where patterns are not just solely asking about types and maybe with a guard, but actually they're doing more work and they're actually deconstructing the value for you. So records are a great candidate for this, and they will be the first types that will support deconstruction patterns. And now, if you remember with records, records are special sorts of classes that have what we call components, and all records have the components that appear in the declaration. So, for example, if you say record point and then your components are int x and y, then you know every point has a component x and a component y, both of them of type int. Now, what we're going to do in the future is allow a pattern that not only asks whether the value is a point, in this case, but it also says, if it's a point, please initialize these two pattern variables with the values of x and y from the point. So it will actually both do a type check for you, and it will break apart, if you like, the value and deconstruct it into its component values for you and assign the pattern variables that you supplied with the values of the components. This is kind of like the opposite of a constructor. And you remember with record classes, they always have a canonical constructor. So all record classes have a sort of canonical deconstructor, which is a way of saying, are you a value of that record class type? And if you are, well, then pull yourself apart and give me the two values for the point example. Now, this leads to some very nice looking code where you wrap things up, perhaps with lots of nested record classes. And now your pattern can say, are you a point? Or maybe, are you a colored point containing a point? Are you maybe a bounded colored point containing a colored point containing a point? So now we can nest the patterns in the same way that you can nest constructor calls, because you can say, I'd like to make a new colored point. I would like to pass in this new point, for example. Well, if you can nest the constructors, you ought to be able to nest the deconstructors. So now we get this very beautiful looking code where we start to see really the power of pattern matching, which is not just the type test, but actually more like this template thing I mentioned right at the start of this interview about matching something quite complicated and just saying, I want it to have this sort of shape, and please initialize the variables to these holes here, there, and somewhere else. So we are proposing in JET 405, which again should preview in JDK 18, to support deconstruction patterns for record classes and also for arrays. So we're going to offer a pattern which says, for example, are you a string array? And if you are, can you initialize variable A1 to be the first string, the pattern variable A2 to be the second string, and so on? And this will only match an array with at least two elements. So it matches both the type of the array, but also the size of the array. So we have an ellipsis form to say, to be able to distinguish between exactly this many elements or at least this many elements. So it gives you a way to start checking whether a value is an array and pulling out values all in one pattern test. And really from this JEP onwards, we'll start to see really the power of pattern matching, which is this ability to both have tests based on type, but also tests based on the contents and being allowed to nest all of this together. So we end up writing quite complicated navigation code, if you like, through the value to extract values, sub-values from the initial value. And that, I think, is once we get to that point, I think people are going to be very excited because they will start seeing really how pattern matching can lead to very compact code that is examining complicated nested values.
So will you be able to nest, for example, have an array of records?
Yes, absolutely. So you can have an array of records. Just keep going. So we can write all sorts of exciting stuff. So yeah, I'm very excited about that feature.
Yeah, that sounds really exciting. And more work for the compiler too.
Well, that's fine. I mean, we have brilliant compiler engineers, and wouldn't you prefer the compiler to do the work than you?
Absolutely.
Compiler's very good at doing that. So
Okay. Gavin, we had a very good discussion today. Pattern matching sounds really exciting. So is there anything you'd like to add to conclude?
I would encourage everybody to read the JEPs that are out there and to try out the preview when it's available. You can get early builds already. So please try them. Please give us feedback because these are quite complicated features and significant changes to the language. So we'd love to hear your experience and your thoughts on the design.
Okay, great. Thanks again for coming to the show. It's the second time, but I'm sure it's not the last time.
I'm sure not too. Thank you so much for having me. I really enjoyed it.
Thank you. Bye.
Bye.